Today we're beginning to speak about the normal curve, which really focuses on what a standard deviation is. Standard deviation. Okay, so a standard deviation is basically how spread out or consistent grades are. So if we both are taking a test and one gets a standard deviation of 5 and another test gets a standard deviation of 10, this test with the standard deviation that's smaller is a better test. It's more consistent and less spread out. Okay? Now, these things, this is what we call the normal curve. It's basically just a histogram of number of people. So if you have, but it's curvy, then this number right here, the amount of people that are in this spot right here are a lot. Okay, that's how basically the curve is up really high, means that there's a lot of people or a lot of data in that spot. So the closer to this spot, this is the mean. So this little symbol right here stands for mu, M-U. That's how it's pronounced, and it looks like that. That's another name for mean or average. Okay, and this symbol right here stands for the standard deviation. So one standard deviation above the mean would be right here, so plus one standard deviation, and one standard deviation below the mean would be here. So this many people, so 68% of the people are one standard deviation about, they say it, the mean. Means, that just means above and below. So that distance there, above and below the mean. So that's 68% of people are generally considered, if it's a normal situation and not like super geniuses or that kind of thing, it's considered a normal curve, and one standard deviation will have about 68% of the people that close to the mean. 2 standard deviations out would be from here to here. This would be 2 standard deviations about the mean. Means about, around, that's just what they call it. It's what they say. So that would be all the people between these two. So that if you add those up, that's 95% are within 2 standard deviations. Now that's normal. So all the people between 2 standard deviations, between here and here, that's about 95% of the people. So anyone out here, these are what we call outliers or unusual. Okay, I can't spell. Okay? So we're just going to be dealing with this situation. I'm going to show a video in class about a similar thing. All right, there might be some weird editing things that just happened there, but we're going to just move on and pretend that didn't happen. All right, so now we're going to be using this with our normal curve. All right, so we're just different examples of how you might see it and how it can be used. So the national mean, so you see mean, you know that's the middle, right? For a verbal school, whatever, was 428. So we know we put 428 in the middle there because that's the mean. And the standard deviation was 113. So that means the space between each box here is always 113. So there's 113 points will still fall in that 34% area. So each little box here that's the same space is 113 points. So if I want to go up, I'm going to add 113. So the first 113 I'm going to add, I'm going to get 541 for one standard deviation up. And then if I add 113 again, I get 654. So the highest score here for the 95% would be 654. Now, if I want to go below it, still falling in that 34% there, I would subtract 113 because we're going down. So if I subtract 113, I get 315 at this spot right here. And then here I would get subtract another 113, and I would get 202. Awesome. So now let's answer some questions. That's kind of the setup. Let's answer the questions. So the first question is approximately what percent, so we're just going to be using these numbers here, of those taking this test had verbal scores between 315 and 541. So here's 315, here's 541, and so in between we just count up the percentages. So that's 68%. Excuse me, between 541, here's 541, and 654. So in between there is only 13.5. And between 202 and 654, so 202 is right here, and 654 is here, so that's the 95%. Okay, that's kind of how we use this and how it, how it's used. I'm going to make this a little bigger. There we go. All right, so let's set this one up. Same basic idea. So there's 1,000 students. So we know how many students, but remember, this is still percentages. Took a test resulting in a normal distribution of the scores with a mean of 80, so means middle score is 80, and a standard deviation of 5, so that's easy. Every 5, I'm going to go up 85, and this one's 95. Then I'm going to go 75 and 70. So remember, we're adding 5 to go this way and subtracting 5 to go this way. All right. How many students scored within one standard deviation of the mean? So within one standard deviation, that's one up and one back. So it's this percentage. So it's 68%. But that doesn't tell me how many. So what we have to do is 68% of 1,000. So we just do the 0.68 times 1,000. And we get 680. Okay, so within 2 standard deviations of the mean. So same idea, just 2 standard deviations this time. So here's 2 standard deviations back and 2 standard deviations up. We know that's 95%. Now we can always assume that. We really don't need this board to do that. 1 standard deviation is always 68 and 2 is always 95 in a normal distribution. But it's the same deal of 1,000, so I have to do 0.95 times 1,000. So that would be 950 people. Alrighty, moving on. Like lightning, that's what I'm doing. I'm lightning. Okay, at Newfield, there's 170 students that take geometry, let's say. The final exam scores are distributed with a mean of 75. Always look for that mean. That's where it's going. And a standard deviation of 7. So that means we're going to go up 7. To set it up, we're going to make this 82, this 89, this 68, and this 61. Obviously, if you only need 82 to 89, this is a little more work than you needed to do, but whatever. This is the setup. It's easy. How many students, how many, so we're asking how many, not percentage, can be expected to receive a grade of between 82 and 89. So between 82 and 89, we have 13.5% of the people. Okay? So 13.5% of the people and of 170. So remember, we divide that by 100, so we get 1.135 times 170, and we'll get about 23 people are expected to get a grade between 82 and 89. So how about just greater than 82? So that means not just between here and here, but also everything after. So we just add the 13.5 and that 2.5 that I just colored over. Okay, and we get about 16%. And then, so that's 0.16 times 170, which would be about 27. So 4 extra people. There's only 4 people right there. There is 23 there. So you can see that the higher the hill, the more people will be there. All right. If a given test, if a test is given and the results are, say that 1 standard deviation above the mean is 80. So 1 above is 80. And 1 below is 64. So they're not telling us the mean here. They want us to find the mean and the standard deviation. What you have to remember is these spaces are always evenly distributed. So I'm going to just show you how to do this just to find the standard deviation. It's the easiest route to take, and it works for all of them. So all we have to do is subtract these two. So 80 minus 64. So 80 minus 64 is 16. And then you see how many spaces. You've got 1, 2 spaces. So we divide that by 2. So we get the standard deviation here is 8. Okay, so the standard deviation is 8. So to go from 64 to go up to the mean, we do 64 plus 8, and that's going to give us 72 for the mean. Good? Awesome. All right, let's do the next one. Number 5, a test is given, and the results state that 2 standard deviation above the mean is 90. So this is the mean. Oops. Sorry. So this is the mean. This is 1 above the mean. This is 2 above the mean. So 2 above the mean is 90. I'm going to change colors. And 1 below, so here's the mean, and 1 below is 54. So here you can see there's 1, 2, 3 spaces in between. So all we have to do is subtract them, figure out how many spaces are between 90 and 54. So between 90 and 54 is 36. And then there are 3 spaces, so we have to divide that evenly among 3 standard deviations, so that would be 12. So our standard deviation is 12. To get from 54 and to go up, we're going to add 12, so that's going to be the mean is 68, or 66? Yeah, 66. Good? All right, last one, we're just going to show you how to compare here using the answers to 4 and 5, which test is more consistent. So the way that standard deviations work, the higher the standard deviation, the less consistent, the lower, the better. So the mean for number 4 is 72, and the standard deviation is 8. For number 5, the mean was 66, and the standard deviation is 12. So it's this one. Lower standard deviation, more consistent, equals more consistent. The kids did they did closer to the mean than anyone else, less outliers. Okay, so that's it. Have a good day.